What are limits? So I want us to think about what limits are in our everyday life. So in sports, your coach might say, push yourself to your limit. By definition, a limit is the point or level beyond which something cannot go by. So over here, I've drawn a function. F of x equals 2x plus 1. Now I want to remind you, we input x values and we get out y values. So say we're interested in numbers really close to 3, what corresponding y value we'll get. But we don't actually want to use the number 3. So what would we do in that situation? Well, that's where we use limits. We would write the limit of 2x plus 1 as x approaches 3, and we use that arrow as approaches, equals, and what would this equal? Well, we can draw a table to find this out. And over here we'll have x, and over here we'll have f of x. So let's start with some values that are pretty close to 3. So let's start with 2.9 and 2.99. If we were to input these values into x, what would we get? Or essentially, if we were to look up right here, what y value would we get? Well, we would get 6.8 and 6.98. So we can see as we approach 3, as we get closer and closer to 3, our y value is getting closer and closer to 7. So we would say that the limit as x approaches 3 equals 7. Now you might say, alright, that's pretty cool, but why couldn't I have just put in a 3 into my function? So f of 3 equals 2 times 3, which is 6, plus 1 equals 7. It would have given me the exact same answer. Why did I have to use a limit? Well, in this instance, you could have just done that. But many times, our functions have a hole in them. It's called removable discontinuity, but you can just think of it as a hole. So let's take a look at this example. Over here, we're interested in numbers extremely close to 2, but that do not include 2. However, if I were just to plug in 2 into my function, I'd get 2 squared, which is going to be 4. 4 minus 4 is 0. 2 minus 2 is 0. So it's going to be 0 divided by 0. 0 divided by 0 is undefined. So there is a hole at that point in the function. So technically, there isn't a value at x equals 2. That's where limits come in. By using limits, we can manipulate the math so that we get an approximation that is super close as if we had plugged in this 2. Why? Because if we plug in 1.9, 1.9 minus 2 will give us a value that is not 0. And therefore, we can use it as a denominator and we can divide this without it being undefined. So in other words, the limit as x approaches 2 gives us a good estimate for the function near this hole. So let's draw a table again. Over here, we're going to have x, and over here, we're going to have f of x. Over here, let's put values that are really close to 2, but that don't include 2, so 1.999, right? And let's see what the corresponding f of x value would be. If we plugged in these numbers into x, what would we get out? Well, we would get 3.9, 3.99, and 3.999. So we can see as x approaches 2, as it gets really close to 2, our f of x is getting really close right over here to 4. So we would say that the limit of x squared minus 4 divided by x minus 2 as x approaches 2 equals 4. So that's what limits are. A limit tells you what value a function is getting close to, right? What value it's getting close to as x gets closer to some number. In this instance, we had 2. In the previous example, we had 3. So I hope this video was helpful. And as always, stay positive.